that total 6 constructors we are going to see the data when 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 the data, whereas the remaining 4 constructors are used while sending the data from your device. So the first thing which we are going to see are the constructors which are used to receive the datagrams. Suppose your machine is acting as a receiver now. Okay, assume that your device is acting as a receiver, and now what you have to do, what you have to construct, what you have to write the code according to. So there are the 2 constructors to create new datagram packet objects when you are receiving some data from the network or from other device, you can say. So the first constructor is the public datagram packet, byte buffer, integer length. The second constructor, what arguments we are using over here, what parameters we are considering, that is byte buffer will be the same, length is also considered, but in the second constructor offset is also considered. Okay, offset is basically the starting point. You can also consider it to be a zero. Okay, a zero value, because usually when you write an array, so suppose you have 5 elements and you have to write those 5 elements in the form of array. So what do you write? You start from 0, 0, 1, 2, 3, 4. So it will be equal to the 5 elements. So similarly, if you are providing offset, so that is you are providing a time limit. Your time limit should start from 0. That is you are assigning. Okay. So when a socket is receiving a datagram, socket, your machine is having a socket. Ultimately, when 2 devices are connected over a network, they communicate through the use of socket. So socket at the receiver end. Okay, so when a socket is receiving a datagram, it stores the datagram's data part in buffer beginning at buffer 0. The initial value, the given time limit will be 0, and continuing until the packet is completely stored or until the length bytes have been written into the buffer. Suppose you are having that length of this data will be 6 bytes. So starting from 0 till 6 till it reaches the end limit. So the buffer at the receiver end will store that data. If the second constructor is used, the storage begins at buffer offset instead. Otherwise, the 2 constructors are identical. Yes, the length must be less than or equal to the buffer length offset. Whatever the length is there of the data, so it should not exceed the limit of your length assigned. Suppose you are assigning the length of your buffer as 10 MB. So you should keep in mind that the datagram packet should be less than or equal to 10 MB only. If it is exceeding than 10 MB, suppose your datagram packet is equals to 11 MB. So in that case, what will happen? The 1 MB data will be lost, because UDP is not reliable, and neither the sender will know that this particular data point is lost, nor the receiver will know that this particular datagram packet or this particular data point is lost from the datagram packet. So the length is to be kept in mind. If you try to construct a datagram packet with a length which is going to overflow the buffer, the constructor will throw an illegal argument exception. Just now as I explained that if your data length is 10 MB and your length of the buffer is also 10 MB, and if in the case that if your data is increasing by 1 MB, that is 11 MB data is there. So what it will happen? It will definitely discard 1 MB and it will throw an illegal argument exception. As it is a runtime exception, so it is not necessary for your code to catch it. Runtime it will be handled. It will be corrected. Yes. It is very much okay that if you are creating a datagram packet less than your given buffer size, buffer length. So obviously that buffer will handle it very smoothly. Yes. The issue is when your data is getting overloaded or when your data size is greater than your buffer length. So in that case issue may arise. But if your datagram packet is less as compared to the buffer length reserved, so there will be no issue. In this case, at most, the first length bytes of buffer will be filled with the datagram is received. Here we have an example. Okay, the code below is creating a new datagram packet. To receive a datagram, the length of the datagram, the size of the datagram will be 8192 bytes. So first of all, you are initializing that the datagram is to be received of so many size, of such a size. So here you are assigning byte buffer. In this byte buffer, you are considering a new byte value, that is 8192. You need to create a datagram packet of this size. So datagram packet, we are using DP as the variable used for datagram packet. You are creating a new datagram packet. In this datagram packet, what you are considering? You are considering the buffer and your buffer length. Now what will happen by using this code? So most of the UDP implementations do not support more than this range. Per datagram, you can only provide 8192 bytes only. It is not acceptable if you go 8193. Okay. The theoretical limit, now we have IPv4 and IPv6. Why IPv4 and IPv6 are considered over here? Because we have also seen that UDP is attached to the IP. TCP functioning is different, but when you talk about UDP, so UDP works with Internet Protocol. Yes, so here ultimately you will be need to considering IPv4 and IPv6. So when you talk about the datagram comprising of IPv4 format, so its limit is given as 65,507 bytes of data. And similarly, this much bytes of data and its buffer will also be of this 65,507 byte buffer will be considered in IPv4 datagram. And when you are talking about IPv6, so in IPv6 the limitation is exceeded. The limitation here is 65,536 bytes. Your buffer can be equal to 65,536 and your datagram packet can be less than this value or equal to this value. It cannot be greater than 65,536 when you are considering IPv6, and when you are considering IPv4 type of datagram, so the last limit will be 65,507. Okay.